In this video, we're going to talk about the rocRand library, which generates random numbers. There are two types of random numbers that are commonly generated. One type of random numbers is pseudo-random numbers, and the other type of random number is quasi-random numbers. I tried to use a Python program to generate some pseudo-random numbers and quasi-random numbers. On the left, you can see this distribution of pseudo-random numbers. It has a uniform distribution between 0 and 1, and also 0 on the y-axis. As you can see, it may not look like that random because there are some clusterings, but those are just illusions. Because these random numbers are independent from each other, that's why you can see those clustering effects. Sometimes you want pseudo-random numbers to avoid any expectation of the user. For example, when you play a game like slicing fruits on your iPhone, you probably want to use pseudo-random numbers because you don't want the user to expect what type of fruit will pop up in the next scene. But sometimes pseudo-random number is not the best option. When you want to perform some structuralized design space exploration, you probably do not want to re-explore an area like here. You want to evenly explore the whole area. In this case, you probably want to use some quasi-random numbers. For example, if you are listening to a playlist, you want to randomize your play. It's better to use a quasi-random numbers so that you can avoid two songs from the same singer to be played next to each other. rocRand libraries is actually very simple. It's much simpler than ROC+, ROC Sparse, and ROC-FFT libraries. So we directly talk about the rocRand APIs. At the beginning, we include the necessary header files. Then, we use the regular heap API to allocate some memory buffer. The only special thing here is we want to create a generator which is represented by this variable gen. It has the type of rocRand generator. We're creating two buffers, one device buffer and one is host buffer. You should already be very familiar with this type of code. Then, we want to create a generator. We need to tell rocRand what type of generator that we want to create. Here, we want to create a pseudo-random generator with a default distribution. Next, we can use this createGenerator API to create a generator. We need to tell rocRand library that we want to use a pseudo-random generator. Next, we set a seed that the generator wants to use. As commonly used in random number generation, we set a seed to the current time. Then we call this generate a uniform operation, which generates the random numbers in a uniform distribution. So you can see the rocRand library is so simple, and we only use 3 APIs here. After the rocRand generate uniform API is called, we have the random numbers ready. Then we can copy the random numbers generated to the host using this regular heap memory copy API. We can print the random numbers out. Finally, as usual, we clean up the environment. We destroy the random number generator, and we free the buffer. The rocRand library provides many generator functions that can generate different types of random numbers. We can change the distribution, and we can also change the data type. For example, we can generate integer random numbers that have different data types from uint32, uint8, and uint16. We can generate uniform distribution random numbers in uint32, single precision, double precision, and half precision data. We can also generate numbers in normal distribution and the log normal distribution in different data types including single precision, double precision, and half precision. Finally, we can also generate random numbers that follows Poisson distribution, which is commonly used for Q modeling.